Now, let's read question 1. Global Events Limited has a dynamic website on-premises servers in the USA. For a product launch in Europe, they need to optimize site loading for European users, but the backend must stay in the USA. A quick solution is needed for the imminent launch. What should be recommended? Select one answer. Review the answer choices on screen. The correct answer is option B. CloudFront's Edge Cache closes the Atlantic latency gap. Amazon CloudFront, a global content delivery network, CDN, can cache dynamic and static content at edge locations worldwide, including Europe. By setting the on-premises servers as a custom origin, CloudFront serves content to European users from a nearby edge location, fetching from the US origin if needed. This significantly improves loading times for European users while keeping the backend in the US and is relatively quick to implement. Hey everyone, welcome back to Stack Lessons. Got 10 fresh questions for you today, focused on RDS Proxy connection pooling, SQS event buffering for Lambda, and CloudWatch container insights. Read along, hit pause if you need to, and use the 6-second timer to lock in your answer. Let's go. Keep a running tally. We compare scores in the comments afterwards. Now, question 2. Do the logic before the recall. Demo and Vaxis Alert runs customer demonstration environments on EC2 instances, each in its own VPC. The operations team needs notification when RDP or SSH access to any environment is established. What is the recommended approach? Select one answer. Review the answer choices on screen. The correct answer is option D. GuardDuty detects threats. Flow logs detect connections. VPC flow logs capture IP traffic information for network interfaces in your VPC. By publishing these to CloudWatch logs, you can create metric filters to specifically look for accepted connections on RDP, TCP port 3389, or SSH, TC port 22. CloudWatch alarms can then be set up based on these metrics, triggering notifications, e.g. via SNS, when such access is detected, providing an alert mechanism for established RDP SSH sessions. Time for another one. Question 3. Do not answer a different question. Logi Analytics, Inc. needs to analyze application log files, which are in JSON format and stored in an Amazon S3 bucket. The analysis involves straightforward ad hoc queries. A solutions architect must enable this analysis with the least possible modification to the current setup and minimal operational overhead. What should the architect recommend? Select one answer. Review the answer choices on screen. The correct answer is option D. Athena queries S3 in place. No ETL, no infra. Amazon Athena is an interactive query service designed to analyze data directly in Amazon S3 using standard SQL. It's serverless, requiring no infrastructure setup or management. This allows Logi Analytics Inc. to perform ad hoc queries on their JSON logs with minimal changes in operational burden, as Athena can directly query S3 data. Time for another one. Question 4. Follow the operational constraint. On-Prem Ad Connect uses an on-premises Microsoft Active Directory and wants to give a customer SFTP access to download files stored in Amazon S3 using their existing AD credentials. The customer's application uses an SFTP client. The solution should have minimal operational overhead and no changes to the customer's app. What's best? Select one answer. Review the answer choices on screen. The correct answer is option D. Transfer Family manages SFTP, so you never run an SFTP server. AWS Transfer Family supports SFTP and other protocols for accessing data in Amazon S3. It can integrate with Microsoft Active Directory via AWS Directory Service options like AD Connector or AWS Managed Microsoft ADIS to authenticate users with their existing AD credentials. This allows the customer to use their SFTP client and AD identity without application changes, while AWS Transfer Family provides a managed low-overhead SFTP service. Ready? Question 5. Track every qualifier. Auto-scaling audit needs to ensure all EC2 instances provisioned via auto-scaling groups successfully send reports to a new auditing system immediately upon launch and just before termination. What solution achieves these goals most efficiently for reporting instance lifecycle events? Select one answer. Review the answer choices on screen. The correct answer is option C. Most efficiently signals a native hook, not a polling loop. EC2 auto-scaling lifecycle hooks allow you to perform custom actions as instances are launched or terminated by an auto-scaling group. You can configure a lifecycle hook to pause the instance state transition, launching or terminating, and send a notification, e.g. to an SNS topic, SQS queue, or invoke a Lambda function. This target can then execute a script or process to send the necessary report to the auditing system before the instance proceeds to the next state, e.g. in service or terminated. This provides an efficient and integrated way to capture these lifecycle events. CloudFront for edge delivery, Flowlog port alerts, Athena serverless queries, Transfer Family SFTP, and ASG lifecycle hooks, all managed zero DIY. Ready? Question 6. Find what the distractors miss. Secure Share Inc. recently engaged an AWS Managed Service Provider MSP partner for an application migration. A solutions architect needs to securely share an Amazon machine image, AMIIF, from an existing AWS account with the MSP partner's AWS account. The AMI is EBS-backed and uses an AWS KMS customer-managed key to encrypt its EBS snapshots. What is the most secure way to share this encrypted AMI? Select one answer. Review the answer choices on screen. The correct answer is option A. Sharing the AMI alone leaves the KMS gate locked. To share an AMI encrypted with a customer-managed KMS key, two steps are crucial for security and functionality. 1. Share the AMI itself with the MSP's AWS account. 2. Modify the KMS key policy of the key used to encrypt the AMI snapshots to grant the MSP's AWS account permissions to use that key, e.g. for decryption when launching an instance. This ensures the MSP can launch instances from the shared encrypted AMI while maintaining control over key usage. Let us switch gears. Question 7. One detail changes the answer. SAA database DR needs a disaster recovery DR plan for its high-volume software as a service SaaS platform. All critical data for this platform is stored in an Amazon Aurora MySQL DB cluster. The DR strategy must involve replicating data to a secondary AWS region. Which solution will meet these data replication requirements for D most cost effectively? Select one answer. Review the answer choices on screen. The correct answer is option C. Aurora Global DB replicates sub-seconds and idles cheaply in standby. Amazon Aurora Global Database is specifically designed for globally distributed applications, offering managed cross-region replication with very low latency, typically sub-second. It allows you to have read-only secondary clusters in other AWS regions that can be quickly promoted to full read-write capability in a disaster recovery scenario. For cost effectiveness in a DR setup where the secondary region is primarily a standby, you can provision minimal resources, e.g. a single small reader instance, in that secondary region. These resources can then be scaled up rapidly if a failover becomes necessary. This provides a robust DR posture with more controlled ongoing costs for the standby region compared to a fully provisioned, actively replicating setup via DNS for DR. Let us switch gears. Question 8. Anchor on the exact workload. Order System Resilience operates an e-commerce application that uses Amazon API Gateway and an AWS Lambda function, with data persisted in an Amazon Aurora PostgreSQL database. During a recent high-traffic sales event, customers experienced timeouts, and some orders were not processed. Analysis showed high CPU and memory utilization on the database due to a large number of open connections. A solution is needed to prevent these timeout errors with minimal changes to the existing application code. What should be implemented? Select one answer. Review the answer choices on screen. The correct answer is option A. RDS Proxy multiplexes Lambdas burst into a steady connection pool. Amazon RDS Proxy is a fully managed, highly available database proxy that sits between your application and your RDS Aurora database. It excels at pooling and sharing database connections, which is particularly beneficial for serverless applications like AWS Lambda that can open many short-lived connections. By routing database connections through RDS Proxy, you can significantly reduce the load on the database from managing numerous connections, improve application scalability, and enhance resilience to database failovers or high connection loads, all with minimal code changes, typically just updating the connection endpoint in the Lambda function. The timeout problem here is really a math problem. Let's put the numbers on screen. Imagine your flash sale hits. Lambda scales to 1,000 concurrent instances. That's 1,000 open database connections at once. Your Aurora db.t3.medium can only handle 341. The math doesn't work, so you get timeouts. Option C, scaling up the database buys more headroom, but you're still racing Lambda's scale. RDS Proxy breaks that race. It accepts all 1,000 Lambda connections and keeps maybe 50 actual connections to Aurora. Lambda talks to the proxy. The proxy talks to the database. Same code, minimal change. That's why A wins over C. Keep your focus here. Question 9. Look for the answer that fully satisfies it. Doc Processavers Corp. deployed a serverless application where new document uploads to an S3 bucket trigger an AWS Lambda function for processing. Following a recent marketing campaign that caused a surge in uploads, the company noticed that a significant number of documents were not processed by the Lambda function. What architectural improvement should a solutions architect implement to enhance the reliability of this application? Select one answer. Review the answer choices on screen. The correct answer is option B. Not processed means throttled or dropped. Cue it. Direct S3 to Lambda invocations can sometimes overwhelm Lambda functions during sudden, high-volume bursts of events, potentially leading to throttling or missed invocations if not handled with concurrency limits and error configurations. Introducing an Amazon SQS queue as an intermediary buffer between S3 and Lambda significantly improves reliability and resilience. S3 events are sent as messages to the SQS queue. The Lambda function then pulls this queue for messages to process. This decouples the services, allows Lambda to process messages at a sustainable rate, and handles retries more effectively. A dead letter queue, DLQ, associated with the SQS queue captures messages that consistently fail processing after several attempts, preventing data loss and allowing for later investigation and reprocessing if necessary. Here's why direct S3 to Lambda triggers can fail you during a traffic surge, and how to fix it. Imagine a pizza shop on game day. 500 orders at once. If you take orders at the door directly, customers get turned away. But tickets let everyone queue, and you work through them at your own pace. That's exactly what SQS does here. Your S3 bucket gets 10,000 document uploads in an hour. Without a queue in the middle, Lambda gets hit directly. Under a surge, It throttles and drops events. With SQS in place, S3 puts each upload into the queue. Lambda then pulls that queue at a steady rate. And if a document fails processing 3 times, it lands in a dead letter queue for you to fix later. That's why the queue wins. It decouples the spike from the processor. All right, for question 10, the qualifier matters. EKSM Monitoring Centralized has deployed a critical customer-facing application on Amazon Elastic Kubernetes Service, Amazon EKS. This application follows a microservices architecture. The company needs to implement a comprehensive solution that collects, aggregates, and summarizes key performance metrics and application logs from all components of this EKS application, including pods, nodes, and control plane, if applicable, in a centralized location for easy monitoring and troubleshooting. Which AWS monitoring solution is specifically designed for this purpose and meets these requirements? Select one answer. Review the answer choices on screen. The correct answer is option D. Prometheus is valid. Container Insights is the exam's managed answer. Amazon CloudWatch Container Insights is a feature specifically designed for collecting, aggregating, and summarizing metrics and logs from containerized applications and microservices running on Amazon EKS and Amazon ECS. When enabled for an EKS cluster, Container Insights automatically collects performance metrics such as CPU, memory, disk I/O, and network traffic at various levels including cluster, node, pod, container, and service. It also collects application logs and EKS control plane logs, if enabled. This data is sent to CloudWatch, where it can be visualized on pre-built dashboards, queried using CloudWatch Logs Insights, and used to set alarms. This provides a centralized and comprehensive monitoring solution with minimal setup for EKS environments. This question is really about knowing when AWS has a native solution built for the job. Imagine your microservices app has 30 pods across 10 nodes on EKS. Something breaks at 2 a.m. You need metrics, logs, and dashboards. Fast. Option A sounds tempting. Put a CloudWatch agent on every worker node, but it only captures system-level metrics. Pod-level data is missing. Option C means self-hosting Prometheus and Grafana, which is more infra to babysit. Container Insights, the AWS native monitoring feature for containers, is the better path. Enable it once and it auto-collects metrics at every level: cluster, node, pod, and container. Log and control plane data come along too, with pre-built dashboards already waiting in CloudWatch. The exam rewards the built for this answer, not the DIY workaround. 3 takeaways from this session. First, RDS Proxy multiplexes Lambda's hundreds of connections into dozens, preventing Aurora exhaustion with one endpoint change. Second, inserting SQS between S3 and Lambda converts all-or-nothing burst invocations into a retriable, DLQ-backed message stream. Third, Container Insights on EKS gives automatic pod-level metrics and logs. Deploying Prometheus yourself adds overhead the exam penalizes. The move here was always the same. Slot in the managed AWS layer and let it absorb the load, the burst, or the complexity. Master that instinct and the hard questions get a lot easier. Quick favor before the next set. If this helped, hit subscribe. It's the simplest way to support the channel and reach more learners. Tell me your score in the comments and where you struggled. If you'd like a series on a different certification, suggest it below. And if there's anything about the speed or the style you'd change, I want to hear it.